Right, so conservation of momentum. First thing you want to know is what is momentum? So starting from the very familiar equation, F equals ma. Now, what is A? A is your change in velocity over your change in time. Now, say I want to plug this in back in here. I have F equals m, change in velocity, over change in time. But now, what is m times velocity? You know that mv equals this little thing rho, or p, whatever you want to call it, which is momentum. So then since there's a change in here, you could say that your force is simply the change in momentum, I'm going to name it p, divided by the change in time. Now, conservation of momentum means that this does not change. In other words, your change in momentum equals your momentum final minus your momentum initial. Conservation means that this equals 0. So if this equals 0, therefore forces, all net forces equal 0. That does not mean that there are no forces involved. This just means that the net force is 0. So this means that, say for example, you have a little box here, and then on one side you have some person, and on the other side you have some other person, and they're playing tug of war with the little box in the middle because that's what they like doing. Well, if this one is pulling this way with T, and this one is pulling that way with T, if you draw a free body diagram, you're going to see that it's going to have T, and by the way, these two T's equal, and T is going to be F, which equals ma, which equals T minus T, and since these two are equal, this is 0. So my net force is 0. Therefore, I could go ahead and apply conservation of momentum. Now, again, what does this mean? Again, conservation of momentum means that this is 0 since the top is 0. Your time still does change, so whatever you get here doesn't matter because 0 over whatever it is still 0. So, again, this means that your mv final equals mv initial. So, when do you want to use this? An example could be you have two balls and they collide, and this one goes off one way and this one goes off another way. Well, your initial momentum here was just the mv of 1, right, initial, and then this is going to have some v final of 2, m2, this is going to be that same m1, v1, but final, right? So you're going to add this plus this, which is your total momentum. It's going to be m1, v1, plus, since this v is 0, since it's stationary, it's 0, is going to equal your m2, vf2, plus m1, v1, but final, right? So this means that you could just take this out, and you can go ahead and play around with this equation, and that is what conservation of momentum is just being able to play around with this equation. But remember, it's only when your net force is 0.